Hello everyone, I'm Paul and today we're solving problem 2210, count hills and valleys in an array. Here it says this is easy, but I would say this is actually like a medium easy. So next I will show you my intuition, approach and efficient solution. We are given an integer array nums such as this one, and this is our job. We need to return the number of hills and valleys in the array. For example, this is a hill, because the closest non-equal neighbor to the left, meaning this, is smaller, and the closest non-equal neighbor to the right is also smaller. So this is a hill. This is also a hill because 6 is greater than 1 and it's also greater than 5. And this is a valley because the closest non-equal neighbor to the left is greater and the closest non-equal neighbor to the right, meaning this, is also greater. And given that both of these neighbors are greater, here we have a valley. And this part is very important. Adjacent indices are part of the same hill and valley if they correspond to the same number. For example, here we have the same consecutive number. And remember, this is a valley, meaning this entire thing is a valley. Now remember, this is a hill, this is also a hill, so here we have 2 hills and 1 valley, and 2 plus 1 is 3, so we return 3. Now there are many ways to solve this, and here I will show you what I think is the most intuitive. We will iterate this from index 1 to n minus 2. So we'll have an I pointer which will be initially here at index 1. And from here, we will create 2 pointers each time, left and right pointers. First, the left pointer will be at I minus 1, meaning here. And the right pointer will be initially at I plus 1, meaning here in this case. And now we are checking if nums at I is greater than nums at L and nums at I is greater than nums at right, we have a hill. So in this case we add 1 to the result, and now we update the current index to the position corresponding to the right pointer. So now we are here. The left pointer will always be at I minus 1, meaning here in this case, and the right pointer will be initially here at I plus 1. And remember, we can have duplicate values here. So we will use this right pointer to skip duplicates, and we will do the following. While the value at the right pointer is equal to the value at the current index, we update right, and given that 1 is equal to 1, we update right 1 step to the right. Remember, we are doing this because we are trying to find non-equal neighbors. So the first non-equal neighbor from here is 6. So now the right pointer is here. And now we are checking if this value is greater than these 2 values or is smaller than these 2 values. We need to add 1 to the result. In this case, 1 is more than 4 and it's smaller than 6. So we add 1 to the result, and this is now 2. And now we update the I pointer to the position corresponding to the right pointer. So now I is here and we do the same. First, the left pointer is at I minus 1 and the right pointer is at I plus 1, meaning here. Given that this and this are different, we can continue and check if this value is greater than these 2 or if this is smaller than these 2. In this case, this is greater, so here we have a hill, meaning we add 1 to the result. This is now 3. Now we move the I pointer to a position corresponding to the right pointer and we reach the end, because remember that we are iterating this from index 1 to n minus 2. So we return the result, which is 3. So this is it for the approach. Time complexity will be big O of n because we are iterating this, and space complexity will be big O of 1. So now let's go with the code and hopefully you will get the idea. First we say n is length of nums and result is 0 initially, and we want to return this result. And here in between, first I is 1, and remember we are going from 1 to n minus 2. So we'll say while I is smaller than n minus 1. First we'll say the left pointer is I minus 1 and the right pointer is I plus 1. And now we want to skip repeated values to the right. So we say while right is smaller than n and nums right equals nums I, right plus equal 1. And if we reach the end of the array, meaning if right equals n, we break the loop. Next, we want to check if we have a hill, a valley, or none of this. So a hill is when nums left is smaller than nums I and nums right is smaller than nums I. And a valley is the opposite, when nums left is greater than nums I and nums right is greater than nums I. So now we can say if we have a hill or a valley, we add 1 to the result. And finally, we update the I pointer to the position corresponding to the right pointer. And we return the final result. So this is it for the code, and now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.